Now let's move back and use the previous results to determine the original rate that we write in the contract, okay? The fixed rate in the forward rate agreement. The result is the following. The rate that we write in the contract is capital F, needs to equal the forward rate that we observe in the market. So I'm going to look at the LIBOR curve, and I'm going to compute the forward rate for the term of the forward rate agreement, and that forward rate that I compute is the rate that I should set, that I should write in the contract. Okay. So why is that? Well, the idea is the following. The idea is that by definition, this contract at time 0 does not require any payment from either counterparty. Okay. Neither the bank pays the firm nor the firm pays the bank. Okay. So the value of the contract has to be 0 at time 0. Okay. So what we will do is we will go back to the previous equation that we had that determined the value of the contract at any moment in time. We will set that time to 0, and we will force that equation that was up there, equation 4.1, to give us a value of 0. Okay. So if we solve that equation, this is the expression we have. Okay. And now let me just go through these steps here because it will be important later on, right? So this part here is just by rearranging the equation. From the first line to the second line, what I'm changing here is just the right-hand side. And what I'm writing here is the following. This is a spot discount factor for T1. This is a spot discount factor for T2. But what I have here is a forward discount factor between T1 and T2, okay? If you write by definition what is the forward discount factor between T1 and T2, you will see that it is related to the spot discount factors exactly like this, all right? Now from the second to the third line, what I have here is 1 over a discount factors. So this is the inverse of discounting. The inverse of discounting is compounding. So the inverse of going backward in time is going forward in time. So the inverse of discounting is compounding. So I'm going to compound between T1 and T2 using what this is written here is that I am using the forward rate. Okay. So instead of using a discount factor, I am using a forward rate. And I am again compounding because this is raised to a positive exponent to 1. Right? So basically, for the contract to have a value of 0, the left-hand side must equal the right-hand side, meaning that the rate that I write in the contract has to equal the forward rate that I compute from the current term structure of interest rates, which is represented here by these discount factors. Okay. Quick example. So these are the money market rates that I observe in the market today for 1 month. So think of the 1 month LIBOR, for example, which is written, or which is quoted in the market as an annual rate with monthly compounding. Let's say it's 1%. The 3-month rate, which if it was the LIBOR, it would be quoted in the market as an annual rate with quarterly compounding. Let's say it's 1.2%. Okay, and I want to determine what rate should I quote if I am a market maker. What rate should I quote on a forward rate agreement between 1 and 3 months. That's what this notation here means, between 1 and 3. Okay. So again, with the timeline, this is the spot rate that I observe in the market, 1%. This is the spot rate that I observe in the market for 3 months, 1.2%. And I want to determine the forward rate agreement quote for this period here. Right, which would be quoted as an F6 because this is a 2-month period. There are 6 of those in a year, and in the market this is sometimes referred to as a forward rate agreement 1/3. Okay, as we just discussed, this rate that I will quote has to equal the forward rate. So let's compute the forward rate. Compounding from here to here using this rate, which is this left-hand side, has to equal to compound once with this rate, okay, this term here, and then compounding a second second term with this forward rate here. Okay, so solving for this F gives me the rate that I should write in the forward contract. All right. As an alternative, it is also useful to do the following. We are going to arrive at the same result through a different argument. Okay. The argument is the following. Let's think of a market maker, so a bank that is quoting forward rate agreements. Okay, he's quoting a bid and an ask, so it has his desk open, and some firm may come up and hit one of these quotes. Okay, if that happens, then this market maker has to hedge this exposure that was just created. So what we're going to do is to look at the hedging strategy of the market maker and then get to the conclusion that the hedging strategy of the market maker requires the price to be exactly the same as we defined before. Okay, but we are going to do this because it's useful for more advanced type of exercises that we can do. Okay. All right. So let's say that case one. Let's say that the firm chooses to hit a quote that makes the bank, the market maker, pay fixed in the forward rate agreement. Okay. So if that is the case, the bank is committed to the following payments, right? Through the forward rate agreement. Okay. So the bank is going to pay fixed, which means that at the end of the contract, so here we are assuming that the settlement is at the end, okay, we are going to have a minus in the fixed leg, okay, and if the bank is paying fixed, it's receiving floating, so it will have a plus on the floating leg. All right. So basically, the market maker does not like this situation because there is risk here in the sense that as of time zero today, I don't know what's going to be the value of this index, of this floating leg, and therefore, if I leave this contract unhedged, I may get to the end and either make or lose money. So that's not the goal of the market maker. He wants to do a hedging strategy on top of this to eliminate this uncertainty here that comes again from this value that is not known. All right. So let's see what is the trading strategy that we need to do. So again, I'm repeating here what is the exposure that comes from the derivative for the market maker, right? The problem is this. So what I need to do is the following. I need to trades in the money market right now, or commit to doing those trades at some point in the future, such that I get rid of the uncertainty. Okay. So what I'm going to do is the following. I'm going to look at this cash flow here, that is the one that is causing the problem, and think what is the trade that I will need to do to cancel this cash flow, meaning I need to have something that will generate exactly the symmetric. So this cash flow here is exactly the same as the one that is the problem, but with a minus sign, okay, so that the two things cancel out, right? So first, if I have something here that has a minus, means that I am paying money at that moment. So the transaction that generates a payment here is something where I first get money. Okay, so if I first get money and later pay money, this looks like a loan. I first borrow, receive, and then pay. Now the question is how much? Well, if I look at this, this is what? This is just the notional amount compounded at some rate. Okay, so this is basically what? This is basically just a loan at this interest rate. Okay, so if I borrow N dollars at this moment T1, at the rate that will be on the market at that moment, which will be exactly this index, this LIBOR rate, okay, at time T1, at the end of the period, which will be T2, I will pay exactly principal plus interest. Okay, so I'm going to commit to this loan of N at time T1. Again, the point was this whole thing here cancels with this whole thing here. All right, so that's good. But now I still have here this cash flow in the middle of the period, which I don't want. So I'm going to do a second transaction, which will cancel, which will have a opposite sign and the same amount, okay? So again, I need to think of something that I will do before that will generate this cash flow of N there, right? Again, the sign is the same, so this will be a payment. It has to be a loan here that I will do. So a loan that I will do today, such that the amount that I have to pay at time t1 is exactly N. Well, what is that? Is the present value of N. So today, at time 0, I have to borrow the present value of N. Okay, so N times the discount factor. Result, this N cancels with that. So this cancels this one had cancelled with this one. So at this point, I'm almost done. I have one cash flow here, which is perfectly known. This is a number, it's fixed, because it only depends on the spot discount factor that I can observe in the market today. I have another cash flow here at the end of the contract, which is fixed, because everything here is known. Okay. The only problem now is that these two are happening in different points in time, and I cannot really compare money in different points in time. Okay. So the only thing I'm going to do now is to move this amount of money from today to the end. So I'm going to take the full amount of money, and I'm going to invest it. Right? Hence the minus sign. So invest that same amount such that it cancels, and invest it at what? Invest it for the full period until time 2. So when I get to the end, I have what? I have the principal that I started with, which is this part here, plus interest, okay? Compounding is the inverse of discounting. So just to make this more convenient, instead of writing 1 plus some rate, I am dividing by the discount factor, okay? So that gives me exactly what I want. Everything here cancels. The only thing that I have left is this first payment that did not cancel with anything, and this last payment, right? So at time 0, the cash flow is 0. Time t1, the cash flow is t1, perfectly hedged. And I have this cash flow at the end of the trade, okay, at time t2, okay? And everything here is fixed. These are spot discount factors, and this is the rate that I'm going to write in the contract, right? So I will be perfect, the bank, the market maker will be perfectly hedged if this amount is 0. Right? So I'm going to set this cash flow to 0, okay? And this is exactly the equation we had before when we did the proof in the first alternative, right? So again, the result from this is that the rate that the market maker will quote is exactly the result we had got before, which is the forward rate. All right, and I'll stop here.